Welcome to the digital frontier, where artificial intelligence solves complex puzzles and optimizes our world. Today we're diving into one of the cornerstones of AI problem solving, the Constraint Satisfaction Problem, or CSP. Let's explore how CSPs are the key to unlocking efficiencies in scheduling, planning, and beyond. At its core, a constraint satisfaction problem involves finding a solution that satisfies a set of constraints. Imagine trying to complete a jigsaw puzzle where each piece has its specific place. In the world of AI, these puzzles can be anything from scheduling tasks to assigning frequencies to radio stations without interference. CSPs are tackled using variables, domains, and constraints. Variables are the elements we're trying to assign. Domains are the possible values each variable can take, and constraints are the rules that must be followed. Through techniques like backtracking, forward-checking, and heuristic methods, AI systems navigate through these constraints to find optimal solutions. The applications of CSPs are vast and varied, from automating schedules to optimizing logistics and managing resources in video games. CSPs help in making decisions that are both efficient and effective, showcasing the power of AI in solving real-world problems. Despite their potential, CSPs come with their challenges, such as scalability and complexity. However, with advancements in AI and machine learning, we're developing more sophisticated algorithms to tackle these issues, paving the way for smarter, more capable AI systems. Constraint satisfaction problems are at the heart of artificial intelligence, pushing the boundaries of what machines can do for us. As we continue to explore and innovate, the solutions to these complex puzzles will lead us into a future where AI's potential is boundless.